Hi, my name is Jan Wilczek from thewolfsound.com. Welcome to WolfTalk, a podcast about audio programming. In this podcast, you will learn how to build your career in programming or research related to audio, meet programmers and researchers from all around the world, and learn about the intricacies of sound. Hi everyone, and welcome to the 19th episode of the WolfTalk podcast. Today I'm very excited because I have a very special guest for you, namely Chase Kanipe. He's a cybersecurity professional, a musician, and an audio programmer using initially C++ with JUCE and now transitioning to Rust. He's an incredibly productive individual. He gave already 2 ADC talks, so audio developer conference talks. One was on tips how to protect your plugins from cracking them by a hacker, so how to keep your license checking in place. And the second one was on writing elegant DSP code in Rust, and that was in November 2023. So I hope this talk will soon be also published on YouTube. Chase has a profound personal culture, and I found a conversation with him and his figure deeply inspiring. So we talked with Ian Hobson on Rust audio programming in the episode 16 of the WolfTalk podcast. But here is yet another perspective on it, which I found also very fresh. All the people, places, and references mentioned in this podcast episode can be found under thewolfsound.com/talk019. Once again, it's thewolfsound.com/talk019. And if you would like to help the podcast somehow, then please consider subscribing to the WolfSound channel on YouTube and hitting there a thumbs up to this video, then also leaving a 5-star review on Apple Podcast or Spotify. And if you want to see someone special during the next episode, then please suggest it also in the comments on YouTube or on the blog. And finally, if you would like to become someone like Chase, an audio programmer, then feel free to check out my free resource, namely the Audio Plugin Developer Checklist, which you can get at thewolfsound.com/checklist. This checklist lists every bit and piece of knowledge that I believe is necessary that you need to learn to become a full-fledged audio programmer. Highly recommended. And now, Chase Kanipe. Hi Chase, thanks for agreeing on this interview. Could you introduce yourself to the audience?
Yeah, thank you. So I'm Chase. I'm currently a graduate student at University of Maryland, College Park. Professionally, I've mostly worked in computer security research, but I've recently begun a sort of foray into audio programming.
Awesome. And could you share maybe how did your interest in music, audio, and programming start? So were you playing some musical instrument maybe?
Yeah, so since this is the podcast, I guess I can give the long version.
Yeah, please go ahead.
Which is, so I started playing piano very young, and it's since been my primary instrument. I've, be forever grateful to my parents for starting me off on that young. I was what they often call classically trained, which means, which at the beginner to intermediate level usually means you learn to sort of mechanically translate sheet music into a performance, which I always had sort of mixed feelings about. But I'd say my interest in music really grew after I joined a band and I started learning to improvise and play by ear. I remember because of my classical training, learning to improvise was it was a whole new world for me. I remember the first time someone handed me a chord chart. I'd never seen a chord chart before. And so I handed it back to them. I was like, this is not for a pianist. What is this? But I eventually learned. Now I mostly just play by ear and improvise. I'm sure my ability to read sheet music has atrophied, but I'm okay with that because I find this new paradigm more enjoyable. So I guess in parallel to that, I developed an interest in technology. When I was quite young, making little circuits and whatnot. I had a parent who was an engineer who facilitated that interest. I remember the sort of confusion of my extended family when at various holidays I would receive like gifts that were bags of like DC motors and coils of wire and resistors and whatnot. But I made great use of these gifts. But for a long time, these interests were very separate. And I actually remember the exact moment that started the convergence of these interests, which was I was on stage playing keyboard with a band. And at the time, it was mostly I played sort of traditional piano parts. And there's a particular synth part I had to play. And we had this sort of new guy who had joined the band who was kind of leading it. And I remember he thought the pad sound I was using was too bright. So I remember him walking back and open what I now know is the EQ in main stage, which is the sort of live version of Logic, and just, taking the high cutoff down to, 1,000 hertz or whatever, and, softening it up a lot. And to my brain at the time, it was like, whoa, I don't know what you just did, but I got to learn how to do this. And so at that point, I kind of caught the, music production bug, the gear acquisition syndrome bug, and then it flowered from there into an interest in, all sorts of music production, music technology, synthesizers, so on and so forth.
Okay, awesome. And how old were you when this transition happened, so to say?
I don't know, maybe 12 to 14, something like that. I don't know.
Okay.
At the time, I almost had no money. So for me, gear acquisition syndrome was like begging my parents for the $30 I needed to buy this like piano sample library. But yeah.
Oh, that's super cool. And then, as I know, then you studied computer science, but then what led you to this decision to study computer science?
Yeah. So, my interest in circuits and kind of related technologies, and, I got interested in programming through programming classes like many people do in high school. And so it was either going to be electrical engineering or software engineering. I ended up choosing software engineering. So I did study at UMD, and I actually started with a double major in computer science and physics because for a while, I thought I wanted to do quantum computing because it's sort of, it will potentially be important to the cybersecurity world because of the potential for quantum computers to break RSA elliptic curves, most of the public key schemes. So I was interested in that for a while, but I eventually decided I wanted to focus on sort of pure computer science. So I dropped the physics major and just graduated with a computer science degree. Okay,
nice. And you did this at the University of Maryland, right? So can you describe maybe shortly how was it? What was your impression of the overall course?
Right. Yeah, so University of Maryland's a very good school, especially for cybersecurity. And that was one of the main reasons I went there. They had an honors college focused on cybersecurity. The whole defense industry is in Maryland. And so the contractors have lots of money to put into the university to spend on cyber-related projects. And so that was one main reasons I went there. I think, people focus on university rankings a lot. And like UMD does pretty well, but at the end of the day, these rankings are really about research output, if it's a research university, not about the quality of the undergraduate education.
Oh, yeah.
And there is sometimes an inverse relationship between a professor's effectiveness at research and their effectiveness at articulating like undergraduate level content, especially when like to them, they've been researching network protocols for 40 years. And so like teaching it to, like, they can't even remember when they didn't know like how TCP worked or whatever. So sometimes, so I think rankings aren't that important unless you are focused on research, calculus 1, programming 1, it's pretty much the same at most universities, has been my sense. So yeah, so I had a great experience at UMD. But I think you can have a great experience, at least in terms of the quality of the course content, at like most, universities.
Yeah, I know it could be like a point of a discussion. I totally agree with what you said. the unfortunate downside of this, I feel that if you have, like a highly ranked university on your CV, it speaks in your favor. And that's quite unfortunate because, well, you may have chosen, not the most popular university because you really wanted to focus on the one particular aspect of, let's say, computer science. In your case, it was cybersecurity. But I hope that maybe the trend is not so strong now on just where you are from, but mostly on what you're doing and what you're driven by. But yeah, it's I think a very, very wise point that it's typically better to follow your interests than the rankings. Yeah, but I think it would be a great discussion on its own. And since you were, this let's say music technology nerd, maybe let's not abuse this word, but I think we know what is meant by this. Did you manage to sneak in some, audio related stuff into your university projects?
Yeah, I don't think I did actually. I probably would have wanted to, but I think most of the projects I had to do were fairly, structured beforehand. I did find time on the side, sort of separately from classes, to learn a little bit about how JUCE worked and things like that, but not for classes.
Okay, nice. That's also impressive because, I imagine that computer science degrees are typically quite demanding in general. So, that's really nice. And I imagine, as I understand, you did the bachelor's of the computer science. And what was your then path after the bachelor's?
Yeah, so immediately after graduating, I worked at a variety of sort of small companies and labs doing cybersecurity research. And sort of simultaneously, I was getting into, audio programming as kind of my main side project. I've always got some sort of side project going on. And that was when I did my first ADC presentation. And I was pretty content splitting my time between these two things for the foreseeable future. And then GPT-3 happened. Okay. And, like many people, I was very impressed with the results OpenAI got from basically just throwing more data at the transformer architecture. And I think like a lot of people have realized this, massive amounts of resources are being deployed. I heard Inflection AI, I think, is building a supercomputer that has like 22,000 H100s. It's going to be the size of 3 football fields. I was like, wow, I need to jump on this train. And so I just recently enrolled back at UMD for a master's in machine learning, which is one of the main things I'm doing now, hoping to catch my knowledge up to the cutting edge.
Okay, nice. And do you have any idea then what you want to do with this knowledge?
Yeah, so hopefully once I'm a little more familiar with the basics and I'm kind of up on the cutting edge in the field, I think I'll probably start working on sort of the alignment safety problem. I think that overlaps well with the sort of hacker mindset and cybersecurity in general. Things like adversarial examples, watermarking, so on and so forth. And then, of course, there's the general problem of reasoning, right, which is sort of the holy grail of what we want these models to do. And, it'll depend if I end up getting into a research group. It'll kind of depend what group I'm in, what problems make sense to work on. And I'm sure I'll eventually get back around to applying what I learned to audio, but I don't currently have a project on the horizon.
Okay, I understand. So, as one can, I think, hear from what you're saying is that you have a big variety of interests. And, one of them, as you said, is this cybersecurity side and cryptography. And why this particular side? Do you have any particular reason for this?
Yeah, I mean, trying to think. I guess when I first got interested in circuits, the main thing I was building was like little combination lock faults and like laser tripwire systems and these other things that a kid can have fun with. And so this sort of naturally, the sort of security mindset was there from pretty young. Why I was interested in security at all, I can't really tell you. I'm not sure. But yeah, it's been there for a long time. And so it was a sort of natural application of my proclivities.
Okay. And, you know, I know that you based your first ADC talk a little bit about this, but could you maybe expand on what should, you know, an audio programmer, in your opinion, know from the cybersecurity field?
Yeah, so I think it's going to depend on what kind of project you're working on, right? And so if you're working on a web-based project, then you're probably going to want to know the basics about, you know, XSS vulnerabilities and CSRF vulnerabilities and things like that. You know, if you're working on a C++ based project, you know, if it's just a local program, you may not care if there's security vulnerabilities in it, if it doesn't connect to the internet or something like that, because it can't be used to, you know, gain access to the PC or privilege escalate or something. But in the case where there is something you need to protect, you know, you'll want to understand, you know, how buffer overflows can lead to vulnerabilities, the ways mismanaging memory can lead to vulnerabilities. And some understanding of that can be useful, not only in improving the security of what you're writing, but also just improving the reliability of your code. Because the same problems that lead to, you know, heap management-based security vulnerabilities also lead to memory leaks and related things. So there's some additional overlap in that way.
Okay, I think that will be a great segue to the next question. But before we jump into this, I wanted to ask you, because, you know, I am not very familiar with cybersecurity, nor was I. That's why I found your ADC22 presentation so interesting. And I think that was also the goal of your presentation, that this kind of looked like A, black magic in some sense, or B, like, you know, one of those Hollywood movies when you have hackers, you know, hacking into software and looking through pages of decompiled binaries. And could you specify maybe one or two entry-level resources for that, you know, a person like me could pick to familiarize themselves with the concepts you've just described? They don't need to be, you know, very approachable, I would imagine, because, you know, as a computer scientist, you need to be, you know, knowledgeable about stuff. You need to be able to learn stuff, but the ones that you would really recommend and as an entry-level stuff.
Yeah, I mean, so if you're trying to understand the basic concepts, there's a number of good YouTube channels. I think Live Overflow is a very popular one. He covers a lot of the basics about, you know, binary exploitation and reverse engineering. There's a lot of reverse engineering tutorials out there. It's been too long since I've looked at them to tell you which ones, but you can, you know, you search the name of the tool and tutorial, and I think, you know, there's tools like Ghidra or Radar 2 was the one I was using in that talk. Yeah, there's a lot of intro tutorials for those that you can look at.
Okay, thanks. And we'll put also links to all these tools in the episode notes as well. So you can check, the audience can check out the links to them there. But thanks a lot, and I'll definitely take a look. So you mentioned memory safety and, you know, memory issues that can potentially lead to software vulnerabilities. And my then immediate thought on this is a connection to the Rust programming language, which boasts to be, you know, very safe in many ways that C or C++ aren't, or at least aren't by default. And I was curious, is it the reason that you started dabbling into Rust, exactly this issue of memory safety?
Yeah, I don't remember super clearly like the first one when I got into Rust, but certainly I was attracted to it because I was very conscious of how hard it is to write C code free of the various problems that can cause it to, that can make it buggy and, create vulnerabilities of various kinds. And so the fact that Rust can guarantee a compile time, as long as you're not using the unsafe keyword, that there's not going to be any buffer overflows, and there won't even be any race conditions at compile time, I found very interesting. I also like Rust a lot, having learned more about it, because it enforces good programming practices because of how the language is designed. So, many people will be familiar with C++ sort of encouraging people to use the ownership memory management model, meaning the sort of unique pointers, shared pointers, where memory is automatically managed by these smart pointers, and you're sort of always tracking what variable owns some data or what function owns some data. And Rust sort of builds this ownership model into the language and how it manages memory, which is probably how you should always be doing it anyway, which is, very useful. I also like the package system a lot. I don't know that this gets talked about as much, but Cargo is truly amazing. I think anytime I'm writing C++, I spend almost as much time fighting CMake or like whatever dependencies I'm messing with in order to get my project to build as I do actually writing the code. And Cargo being able to just, add a line with a link to a GitHub repository, and virtually always it will, seamlessly pulling in dependencies is very useful if, you're trying to program productively.
Okay, that's super interesting in the sense that, you're right, that not as many people maybe mention Cargo. So that leads me to the question that, is there any package manager that you tried for C++, maybe? I don't know that I like, obviously I've used sudo apt-get a lot on Linux to grab dependencies and link to them. I haven't tried anything Cargo-like, although I've used a lot of, build tools like CMake and Meson and whatnot. Okay. And from what you said, I totally agree that Rust encourages good programming practices. And I think that was the privilege. Of course, it's not easy to make, but that was the privilege of Rust when it was being designed, that it, has all the best practices by default. And if you have something great by default, it's then you really need to pay more effort to break this. And that's why I think there are efforts, to have kind of C++ transpiler or a TypeScript for C++, so that you can use a different syntax for C++, which has these good defaults, and then it transpiles to the standard C++. But yeah, it's I think these are great points. And specifically in audio programming, are there any features of Rust that you found helpful apart from the ones that you mentioned?
Yeah, well, I guess in preparation for my last talk, and in developing the library before that, I think I found the iterator and trait system particularly useful. I think Rust, the generic system, makes it a lot easier to write pretty abstract code. And I found there are a lot more applications of that to writing cleaner DSP code than I expected. So yeah, probably the traits and generic system.
Okay, awesome. I think it's a great point, because the less code we can write, which is still as powerful as it would be, I think the better. So that's also a very important point. And since you said that you were learning Rust, like you have been learning Rust quite recently, as I understand, then could you maybe say, as you have it fresh in your mind, what are the best resources that you would recommend for learning Rust? Or at least the ones that for you, were most helpful?
Yeah, I think in the case of Rust, the best resource is probably the official book. There's like the official Rust book, endorsed by the Rust Foundation. Often the sort of, tutorials developed by the company that produces the product aren't as good. I think in this case, the Rust book is truly the best resource to use. So yeah, I think starting there, reading some of it. But I also find that if I'm like truly going to learn something, just like doing tutorials all day is sort of limiting. I think it's best to learn a little bit with the tutorials and then find some project that like really inspires you. And that sort of, and then just follow up on whatever resources you need along the way. Yeah.
Okay, I think that's a great advice. That's a really great advice. And the moment you start writing the code on your own without, hand holding, that's the moment, and you start Googling to get the answers, then that's the moment that you start learning best. So thank you for this point. I'm also curious, because that's what I also, when I hear audio programming and when I hear cybersecurity, one thing in common is the assembly language. And I'm curious, like, did you have to inspect, assembly a lot? Do you feel, proficient with assembly, would you say?
Yeah, right. So, yeah, I mean, I suppose I'm comparatively proficient in assembly. The Intel instruction manual for x86 is like 3,000 pages. So, of course, my knowledge is like quite small compared to what there is to know. But with cybersecurity, reverse engineering, it's very important to be able to read assembly, and sometimes it's useful to be able to write assembly. There's many like competitive cybersecurity challenges, and many of them will require you to handwrite assembly. So yeah, I'm mildly proficient.
Okay, I think that's already better than the average folk, so to say. For example, me in this regard. And I was curious then, because I think learning assembly is quite hard. It is challenging. It's not. I think learning, for example, Rust is comparatively easy to this, and that's of course only my opinion. And could you then maybe name some resources that you found most helpful when you were learning assembly?
Yeah, probably the cyber resources I mentioned before. You're going to want to use resources like that. I think it's good to do some intro to reverse engineering tutorials and like learn how to read assembly first. Mm-hmm. You want to understand like how calling conventions work, how the stack works, so on and so forth. And then once you kind of have the basics of reverse engineering down, then you can start writing it. I don't know off the top of my head the specific resource to use for that, but that would be my general approach to how to relearn assembly.
Okay, thanks. And would you recommend this Intel x86 manual for beginners?
It not for beginners. It's good as a reference.
Okay.
If you need to find some sort of obscure instructions, or you need to, you see some obscure instructions you don't recognize, then you can look at the manual, but it is not a tutorial. So, I would not recommend you look at that if you don't have to.
Okay, so I imagine...
And in general, for audio programmers, I would not recommend that you learn assembly. Was a time... Yeah, I mean, there was a time when like handwriting assembly optimizations with SIMD instructions or whatever made sense. But I think like nowadays, compilers are very clever. The LLVM optimization passes are much smarter than me. They're probably smarter than you. So I find it's best to just write clean code and let the compiler optimize it usually. Though it's good to be conscious of the sort of known limitations of various optimizers, right? So you want to avoid pointer aliasing that might prevent the compiler from vectorizing your code in C++. In Rust, you want to use iterators instead of array indexing, so you don't introduce the overheads of dynamic bounds checking that can prevent it from vectorizing your code. And so sometimes in these contexts, it can be useful to disassemble specific functions to make sure the compiler is doing what you're expecting. But they're really the only knowledge you need is to be able to recognize, oh yes, this is a SIMD instruction, in a SIMD register or not.
So that is a great point. So that to like get it together in audio programming, you in general don't want to handwrite your assembly code, but you should be somewhat familiar with disassembling your compiled binaries and then looking if they contain the instructions that you would likely see in a highly optimized code. Okay. And I think I had I had maybe one more point with the Intel assembly book that it reminded me of the situation with the C++ standard web page. Then it's a great resource for reference, but you would never like to start there in the first place. So yeah, I think I get your point. And we talked a little bit about the educational materials, but from what I understand, you're also a teacher. So could you share what did you teach in your career so far?
Yeah, so at the University of Maryland, I taught, they had a class on Rust. It was like a lower credit, like partial credit class, basically, for undergraduates. And so I taught the Intro to Rust class, all the relevant, concepts, the language itself. So that's what I've taught.
Okay. And then do you remember still what were the biggest struggles with Rust for the students?
Yeah, so I think with Rust specifically, the biggest struggle is definitely getting your head around the ownership model, because I think there is valid bug-free code that the compiler will not let you write because it violates this particular model, which at the beginning can be very annoying when you're used to a sort of other patterns. And once you sort of get used to the Rust way of doing things, then it's quite useful. I think probably the other thing that's more difficult to get your head around is that Rust uses composition as opposed to inheritance. So in Rust, you have these implementations of functions, and you have the trait system, and you can implement traits on various structs. But you don't have sort of traditional inheritance. You can have default implementations of things, but you don't have inheritance. And so there will be, especially for beginners, you'll sort of design the high level structure of the program in your head, having learned how to pattern things, in a C++ style before. And you'll try to translate this directly into Rust. And you'll find that there is literally no way to do what you're trying to do because the compiler will not let you do it. And this will be very frustrating. And you'll go, why did I ever try and learn Rust? I should give up and go back to C++. And I almost did that on this big audio project I've been working on for a while. But eventually you sort of learn the Rust way of doing things. And inevitably you find out that the design of the program is better once you do it the Rust way. And so, or at least I haven't run into a counterexample to that yet. So yeah, that's the other thing that's difficult is, sort of rethinking how the high level structure of your program should work.
Yeah, I think that's a great point. And it always pains me when I look at my Rust code and I see that it was written by someone who is a C++ programmer. So I think I'm still getting there. And do you have any tips for the people who transition from this more procedural background or this class or the traditional OOP environments? Rather than just practicing a lot.
Right. I think practicing a lot. I don't really know. I think my experience was writing things, finding out the Rust compiler wasn't going to let me do it, and then, going back to the drawing board. There are many examples of people on Stack Overflow running into similar problems that I did, and so you can see how the respondents recommended you re-architecture the program. So, yeah, my experience was just iterating on that until I really understood how the trait and composition system worked. Other than that, I guess I would just recommend that you read the compiler messages closely. In C++, a thing that you learn eventually is that you should not trust what the compiler tells you. Because sometimes the compiler will tell you the problem is one thing, and actually the problem, what needs to be changed is, 30 lines one way or the other. The Rust compiler is very good, though. And so you should make sure that you closely understand the error messages because they often are telling you exactly what you need to know. Yeah.
Okay, thank you. Thanks. That's a very concrete point. And maybe to wrap up the discussion on, learning, what would you say are the best resources then to learn audio programming in general? And I think you're a great person to ask this because you had this computer science background, but I imagine you did not have any audio specific classes at the university. So how did you learn this stuff?
Yeah, so I think for me, the best resources, and this will vary per person and what they're trying to do, but I certainly found the classic Designing Audio Effects in C++ book very useful. I have it here.
Oh, nice.
It is the right balance of concrete code applications and introductory DSP information that you need to know. So that's for the sort of DSP basics. I think to learn the tooling, which is the other half, most people want to learn JUCE, and now the sort of audio programming tutorials have become, it seems to me, the standard way that people learn JUCE now. And so, 10 out of 10, I would recommend that.
Okay, nice.
To learn the sort of high, to really learn DSP, I think the Julius Smith textbooks are probably the way to go. For that, you'll need some math background, and many people won't even need to go that route to implement, a basic distortion or whatever. But certainly, if you want to learn DSP in depth, I would recommend those books.
Nice, thanks. That's a great point as well. And I really love that these books are available for free online. That's really amazing. Let us pause here for a moment. In the answer to the last question, Chase mentioned the JUCE C++ framework. What is JUCE? It is a framework, a platform to create audio-specific software products and tools. It is using the C++ programming language. To be more specific, JUCE is a one-stop shop for prototyping, designing, coding, and releasing desktop and mobile audio applications and plugins for digital audio workstations like reverbs, distortion effects, or sound synthesizers. I am very happy to announce that the JUCE C++ framework has become a sponsor of the podcast. I've been successfully using JUCE since 2018, both in my private and professional projects, so I'm delighted to promote them here. The reason I started using JUCE and the reason I still use it today is that it simplifies the interaction with an operating system's audio driver API and allows you to easily control the audio input or output on basically any desktop or mobile device. It alleviates the need to understand audio plugin APIs and allows you to maintain a single code base that can compile to the VST3, AU, AAX, and even CLAP formats. It also comes with a very flexible graphical user interface possibilities that allow you to create a user interface fast if you just want to prototype something, or precisely if you want to implement a very specific design. On top of it, JUCE features a huge number of utilities for audio processing and user interaction. Pricing of JUCE is very affordable even for freelance developers, and you can use it for free for non-commercial applications. To start using JUCE now, go to juice.com, juce.com, download JUCE, and follow their Getting Started guide. I have also put the link to it in the description. Have fun creating audio apps and plugins. And now, back to the interview. So, going on from this, you have founded, as I learned, Procedural Audio, right? An audio programming company. So could you share maybe what is the idea behind the company?
Yeah, so the startup is still in stealth mode, so I won't share too many details. But from a high level, trying to move the envelope forward on generative and procedurally generated music. The frontier in generative music right now seems to mostly be in the modular synthesis world. For those of you familiar with that, I have one back there. You may or may not be able to see it on the camera. But Yeah, I think software offers way more flexibility. And I think the software attempts to, implement generative music systems do not at all take advantage of all the flexibility that software can bring to generative music. So we're working on sort of moving the envelope forward on that. It's been 2 years in the making. We'll see if what we have been working on will be ready by the next ADC or the one after that. We will see. And I'm also interested too in trying to be able to distribute generative music as generative music, where it executes on the sort of listener's computer, as opposed to writing some generative music and then rendering it to an audio file. So, been working on that for a while. We'll see, product details are forthcoming.
Okay, awesome. It sounds very good to me. And music generations is also an area that benefits currently a lot from the deep learning space as well. And how many people are involved? Is it just you, or is there someone else as well?
Yeah, there's 3 of us. There's me, another programmer, and a web developer.
Okay, awesome. So all the best then. And while you're writing code, could you share maybe what is your tech stack?
Yeah, so for the current project, I'm using Dart and Flutter for the front end, and then Rust for the back end. I would not recommend necessarily doing that for most people, because writing your own framework is a lot of work. Most people are just going to want to use JUCE as the pragmatic choice. I started off with JUCE and then ran into limitations, and so I ended up switching and developing my own framework. I do hope to release that eventually, so that people who want to develop with Rust and Dart will be able to do so more easily. But that'll come in the future when our main project is released.
Okay, and just out of curiosity, did you look at the NiPlug Framework written in Rust?
I recognize the name. I can look it up. I'm sure I've seen it.
Okay, so as I understand, it's like a kind of a JUCE-like equivalent for Rust. But you've not dabbled into this.
I've seen this.
Okay.
So if it's mature enough, then eventually I'll switch the VST implementation over to that. I'm using JUCE to load the Dart front end. So I am using JUCE for the sort of VST3 API at the moment. But I may switch over to this if I find it's mature enough.
Okay, nice. And what IDE and operating system are you using for development?
So primarily I use VS Code, and I happen to develop on Mac mostly at the moment. I'm not that attached to Mac. I will eventually need a Windows computer to test it there. And I use Linux to do cyber stuff, and occasionally I develop there. Okay,
nice. Switching gears a little bit. So you did 2 talks at the Audio Developer Conference 2022 and 23, which I enjoyed incredibly, I must say. I really liked them a lot, especially that they were super well structured and prepared. So could you share a little bit maybe about the motivation for these talks, and what was the feedback that you received afterward?
Yeah, so for the first talk, which was on copy protection schemes, basically, I was sort of conscious of the fact that I wanted to branch into the audio space, and I figured a good first step would be to sort of combine the audio and cyber skills I already had. When developing my own copy protection scheme, I, of course, looked at what the JUCE forums had to say, and I saw a lot of bad advice, and also advice that I knew would be useless, like people were recommending all these, things that would allegedly make it more difficult for the cracker, and I was like, this is going to delay them by like 2 minutes. So I was like, okay, maybe because of my sort of cross-disciplinary experience, I have something to contribute here, and so that was the motivation for the first talk. For the second talk, I'd kind of been working on this long-term project using Rust and Dart, and I sort of got to the point where the Rust DSP library I had, I felt it was, mature enough that I'd be able to release it soon. And so that talk was part of me explaining the mechanics of this bit of the long-term project I was preparing to release, and more pieces will come out over time.
Okay, awesome. Thank you for this. And did you get any like feedback afterwards? So were people reaching out to you with I don't know, maybe contracting possibilities? Or
yeah, I had some contract offers. I did a little bit for a few companies. And I've got a few questions related to the cyber one in particular.
Awesome. And are you planning a talk at ADC 2024 maybe?
There's a good chance. I'm currently working on a compiler that may show up at the next ADC, so we'll see.
Awesome.
See if I finish it in time.
I'll definitely attend it because your talks are never to be missed. So while we are heading towards the end of this conversation, I must say that I'm personally, hugely impressed by the scope and the depth of your interest, and I think this is something one can clearly see from the list of the book and video recommendations on your personal website. And I was curious to ask then, where do you get the energy and the motivation to continue this self-development?
Yeah. I guess I don't really know. Who knows where their energy comes from? My general strategy is just to find things I find really inspiring and immerse myself in them. My curiosity has always been turned up fairly high, and so I found it not that difficult to find new things inspiring. It has its downsides, right? Because it can be very distracting to find something new that you're very interested in when there's something you're already working on that needs to be done, and there's always this sunk cost in this old project that you don't want to abandon. And being a true subject matter expert usually requires you immerse yourself in one thing for a decade. And it's harder to do that if you're constantly exploring. So usually I find inspiration gives me energy. If I don't have energy, but I feel something needs to be done, I usually just lay in bed with my laptop and work, because that requires much less energy. So that's how I find energy.
Okay. And then how do you disengage and relax your brain?
So usually that's going to be through playing music of some kind. So historically that's been playing piano. I recently got this piano you see back here. Finally have an acoustic piano after all these years of having electronic ones in dorms. And other instruments, I'm mediocre at guitar, and so that can also be a way to relax. Mostly I just play moody suspended chords on the piano, though.
Nice. And then do you plan to release your own music album with all the music stuff that you're doing?
Yes, I certainly do. It turns out that writing music is very hard, especially if you want to write something differentiated. So I find every, song I write, the day after it's written, I'm like, this is great. Then 3 days later, I'm like, I'm embarrassed I ever wrote this. And so yes, I do plan to. It's been something of a joke with some of my friends. They're always asking me, when is the album coming out? And it's perpetually been a year away. So I feel I've continued to converge on the right sound elements and work, pieces of my workflow. So hopefully 1 year away, the album will be out. I would say the main thing I learned from this experience is that workflow really matters. I used to think that sort of having unlimited possibilities like what software gives you is a good thing. But I've since learned that having too many options only results in choice paralysis and like low productivity. I also find that music is very much an empirical process, in that you're not just going to a priori like conceive of the right melody and like harmonic elements and whatnot that you can just like slowly type into Logic Pro with your keyboard. Rather, it's much more effective to try and improvise something, record that quickly, be able to iterate quickly, try new things. This sort of empirical back and forth that you can get when you have a good workflow. And, it's usually much easier with physical instruments, which are unfortunately very expensive. But I find that to be a much more productive way to write.
Okay, thank you for this insight. So it's also a little bit creativity through constraints than even self-imposed constraints. I think that's really, really powerful. And do you then listen to music while programming?
Sometimes I listen to music, yes.
Okay. And do you have any particular genre or artist that you would like to mention?
Any particular genre or artist? Yeah, I mean, as far as what I'm writing, I've kind of been interested in this, like a sort of unique mix of neoclassical, post-rock, and ambient music. So I guess in those genres, a good post-rock band is Hubris. Another one is called Explosions in the Sky. I think they're more well-known. On the ambient side, Tony Anderson is very good. He's probably my favorite artist. Many of you have seen probably Jameson Nathan Jones on YouTube, and he's done a few interviews with Tony Anderson that I'm very much a fan of. And then neoclassical, of course, Olafur Arnalds is, one of the most inspiring ones. So
nice.
Yes, any of those artists I would recommend.
Yeah, I like him a lot too. That's right. Okay, so we reached the end of the list of the questions. Thank you so much for this interview, for your time. One last thing, that if someone wanted to contact you, where do you recommend they go?
Yeah, so my personal website will have my email, which is just my first name, last name @gmail. So I'd recommend they go there.
Okay. Thank you so much. Thank you, Chase, for sharing all your wealth of knowledge with the audience. And I'm sure that your example will be hugely inspirational for people. And it's definitely an inspiration for me, to learn new stuff, to pursue new interests, and to go deep with them, to immerse myself in them. So thanks a lot. And I wish you all the best with all your many endeavors that you have at hand.
Yeah, thank you. I'm a huge fan of the podcast, so this was great fun.
Thanks. Bye-bye. All right, everyone. That was Chase Kanipe, a Rust audio programmer and an incredibly inspiring individual. Thank you, Chase, for doing this interview. And to you, the listener, if you'd like to check out some people, places, or references mentioned in this podcast episode, they are all listed in the episode notes under thewolfsound.com/talk019. Once again, it's thewolfsound.com/talk019. And if you like the podcast, if you would like to support it somehow, then please consider subscribing to the WolfSound YouTube channel, leaving there a thumbs up under the video, leaving a 5-star review on Apple Podcasts or on Spotify. And is there anyone you would like to see in the next podcast episode, then let me know in the comments on YouTube or in the episode notes. Don't forget about your free resource, the audio plugin developer checklist under thewolfsound.com/checklist. And thank you for listening. See you in the next one. Take care.